Hello students, in our previous video we have discussed the spherical mirrors, important definitions related to spherical mirrors and types of spherical mirror, that is concave mirror and convex mirror. And today we are going to discuss about the rules for obtaining images formed by spherical mirrors or representation of image formed by spherical mirror using ray diagrams. So to find the position and nature of image of an object formed by a spherical mirror, it may be concave mirror or it may be convex mirror, we make a ray diagram. We make a ray diagrams. So large number of rays of light from an object fall on the reflecting surface of the mirror, because each point on an object acts as a source of light, and these rays are then reflected by the mirror and intersect or appear to intersect to form an image of the object. But for our convenience, we generally consider only 2 rays out of the 4 types of rays while making the ray diagrams for locating the image of an object. So first rule or first law of reflection for spherical mirror is when the incident ray of light parallel to the principal axis. Any incident ray of light traveling parallel to principal axis, like this. This is a incident ray that is traveling parallel to the principal axis, or it appears after reflection, it passes or it appears to pass to the principal focus, that is this point. This is incident ray and this is reflected ray. So this is the first case. In case of first is the case for concave mirror. In this case there is actual reflected ray passes through the focus, and in case of a convex mirror, any ray traveling parallel to the principal axis, it generally diverges the light ray. Light will bend outward direction, but if we extend this light ray, it will appears to pass through the focus point. This is the first law of reflection for spherical mirror. The second one is when a ray of light, this is pole, this is focus point, this is center of curvature. The second is a ray of light passing through the focus of a spherical mirror, means this is a focus of a, if any incident ray passes through the focus of the spherical mirror, then after passing through the focus, after reflection, it will become parallel to the principal axis. And in case of convex mirror, this is pole, this is focus, and this is C. And in case of this light rays coming from the source of, it will become parallel to principal axis. The third case is when incident ray of light passing through the center of curvature. Incident light, this is pole, this is focus point, this is center of curvature. When a ray of light passing through the center of curvature of a spherical mirror, then it retraces its path, means there will be no change in the path of light. It will retraces its path. Retraces means this is C, center of curvature. When light ray incident in this way, after reflection it will retraces its path. Similar direction it will move in a backward direction. And in case of the third rule is when light ray passes through the pole. This is pole. When light ray passes through the, this is pole. When light ray incident obliquely on the pole of spherical mirror, then the journey incident ray of light traveling obliquely to the principal axis is reflected obliquely after striking a spherical mirror at its pole. So for these are the 4 rules through which we generally consider any 2 rays to draw the ray diagram for our convenience. So first of all, we will consider. So we will draw the ray diagram in case of concave mirror. This is our concave mirror which has a curved reflecting surface and outer surface is generally polished. What will happen? This is our principal axis. This is our pole. This is focus point. This is focus point. This is center of curvature. This is focus point and this is center of curvature. So let's assume that when object is at infinity, when it is very far from the lens, consider an object A. It is at infinity. Object is at infinity, very far away from the lens. Then 2 parallel rays coming from the object, they strike on the mirror. After incident on a mirror, they meet at a focus point. This ray will meet, and you have to put arrow. This shows the where these 2 light rays meet or intersect. The image of object formed at that place. Thus a point image, very small image, point image of the object is formed at the principal focus of the concave mirror. So we can say that image formed is highly diminished. Very small sized image is formed. Why? Because the ray of light actually intersect each other at that point. So image formed is real. We know that real image is formed due to the actual intersection of the light rays. And real image is always inverted. Means if the object is placed like this, then the image will be inverted upside down. So in this case, when object is infinity, diminished real and inverted image is formed at focus because of the actual intersection of the light rays. The second case is when object is beyond the center of curvature. Center of curvature. So again, when object is beyond center of curvature. This is pole. This is focus point. This is center of curvature, and we have to extend the principal axis in this way. And beyond center of curvature means when the object is at that point. This is an object. Object means anything. It may be tree or it may be anything that we are going to place in front of it and name that AB. Let's consider 2 rays. First one, that is parallel to the principal axis, striking on the mirror. After striking on the mirror, it will pass through the focus point. This is the first ray, and we will consider the second ray. We will consider any two rays, and I am considering here the second ray that is passes through the center of curvature. The ray that passes through the center of curvature, we have just learned that it retraces its path. After reflection, it retraces its path. So where these two light rays intersect, the image will be formed at that point. So at that point, this point lie between the center of curvature and focus point. This is the point. So here the image is formed between center of curvature and F. And the size of the image, and let's name it A dash, B dash. And the size of the image A dash, B dash, we can see here that size of the image is smaller or less than the size of the object. Therefore, a diminished image is formed. Again, it is real because of the actual intersection of the light rays, and it is inverted. So next ray diagrams we will draw in our next video. Thank you.